Hello everyone, my name is Heath Masara and today I'm going to present on the topic designing of contactless eddy braking system. Braking is one of the most essential aspects of any moving vehicle, ensuring safety and control. Traditional braking systems rely on friction which causes wear and tear over time, leading to high maintenance costs and reduced efficiency. However, advancement in technology have led us to explore a more innovative and reliable braking system, the eddy braking system. This system works on the principle of electromagnetism, allowing us to slow down or stop a vehicle without any physical contact. Since there is no friction involved, there is no heat generation, no wear and tear, and very little maintenance required. This makes eddy braking an efficient, durable, and futuristic alternative to traditional braking methods. Today, I will explain how this technology works, its components, advantages, and future applications in modern transportation. Let's get started. Introduction. Braking is one of the most important safety features in any vehicle. It ensures that a vehicle can slow down or stop effectively, preventing accidents and ensuring control while driving. In traditional braking systems, the process relies on friction, where brake pad presses against the rotating wheel or disc to generate resistance and stop the motion. However, this friction-based mechanism has several drawbacks. Over time, continuous friction causes wear and tear on brake components, leading to reduced performance and the need for frequent maintenance. This not only increases the overall cost but also decreases the lifespan of braking system. Additionally, friction generates heat, which can lead to brake fading, reducing effectiveness in prolonged use, such as during downhill driving. To overcome these limitations, engineers have developed an advanced braking technology known as eddy braking. Instead of relying on mechanical friction, this system uses electromagnetic principle to slow down or stop a vehicle without any physical contact. When a conductor moves through a magnetic field, it induces circulating electric currents known as eddy currents. These currents generate an opposing force that resists motion, effectively slowing down the vehicle. The biggest advantage of eddy braking include higher efficiency, minimal maintenance, and increased reliability. Since there are no mechanical parts making direct contact, there is no friction, no heat generation, and no need for lubrication or frequent replacements. This makes eddy braking an ideal solution for modern vehicles, trains, and industrial machinery, offering a more sustainable and long lasting braking alternative. What is electromagnetic braking? Electromagnetic braking is a system that uses electronic, and magnetic power to apply brakes. Unlike conventional brakes that depend on friction, these brakes work without any physical contact. This means there is no heat generation, no wear and tear, and much longer lifespan. Concept of eddy braking. Eddy braking is based on a fundamental scientific principle of electromagnetism, where a conductor such as metal, disc, or wheel moves through a magnetic field. It disturbs the magnetic lines of forces. This disturbance includes circulating electric currents within the conductor, known as eddy currents. These currents follow circular paths within the metal and generate their own opposing magnetic field, which resists their motion of the conductor. This opposing force, known as electromagnetic damping, works like an invisible brake, slowing down the movement of the conductor without any physical contact. The stronger the magnetic field or faster the motion, the greater the induced eddy currents and the stronger the braking effect. This principle is used to design an efficient and frictionless braking system, eliminating the need for mechanical contact, brake pads, or lubrication. Eddy braking is particularly useful in high-speed applications such as trains, roller coasters, and electric vehicles, where traditional friction-based brakes may wear out too quickly or generate too much heat. In summary, eddy braking leverages electromagnetism to provide a smooth, efficient, and maintenance-free braking solution that is ideal for modern transportation and industrial application. Eddy braking process. This slide explains the complete process of eddy brakes in form of a detailed flowchart. Components of eddy braking system. The eddy braking system is made up of four key components, each playing an essential role in ensuring smooth and efficient braking without friction. Let's go through them one by one. Wheel. The rotating component. The wheel is the primary moving part of the system, whether when the vehicle is in motion, the wheel rotates at high speed. Since eddy braking works on the principle of electromagnetic induction, the wheel needs to be made of a conductive metal like aluminum or copper. These materials allow eddy currents to form when exposed to a magnetic field, creating the necessary opposing force to slow down the rotation. Electromagnets. The magnetic field generator. Electromagnets are the heart of the eddy braking system. They create the magnetic field required to generate eddy currents in the rotating wheel. When electricity is passed through these electromagnets, they become magnetized and produce a controlled magnetic flux. The strength of these flux determine how powerful the braking force will be. By increasing or decreasing the electrical output, the braking effect can be adjusted as needed. Controlling circuit. The brain of our system. The controlling circuit regulates the power supply of the electromagnet. It acts like the brain of the system, ensuring that the braking force is applied smoothly and efficiently. When the driver applies the brake, the circuit controls how much current flows to the electromagnets. Adjusting the intensity of the magnetic field, this prevents sudden jerks or abrupt stopping, making the braking process safer and more controlled. Supporting frame, the structural backbone. The supporting frame holds all the components together, ensuring stability and durability. Since the braking system operates without physical contact, the frame primarily serves as structural support to keep the electromagnets in place and aligned while the rotating wheel. It must be designed to withstand external vibration forces and temperature variation, ensuring long-term reliability. Wheel. The wheel in the system should be made of a conductive material like aluminium or copper. This allowed eddy currents to be induced efficiently, making the braking system effective. Electromagnets. Electromagnets are responsible for generating the magnetic field required for braking. The strength of these electromagnets determine how strong the braking force will be. More current is equals to stronger braking effect. Controlling circuit. The controlling circuit manages the electromagnet. It adjusts the power supply based on the braking needs, ensuring the system works smoothly and efficiently without sudden jolts or failures. Supporting frame. The supporting frame is the structure that holds all the components in place. It is designed to withstand the braking force and ensure stability while the system operates. Working principle. Okay, let me explain how the system works. Magnetic field applied. So first we have a rotating wheel like the one on a vehicle. A magnetic field is applied near the wheel and it's at right angle to the wheel surface. Basically, the magnet is placed in a way that it cuts through the wheel as it spins. Eddy currents are created. As the wheel spins to the magnetic field, the changing magnetic field causes electric currents to form inside the wheel. These currents are called eddy currents and they flow in opposite direction of the wheel's rotation. Opposing forces slow down the wheel. Now these eddy currents actually create their own magnetic field that pushes against the original magnetic field. This creates a force that works against the wheel's motion, which slows it down. And the best part, there is no physical contact involved. It's all happening through a magnetic interaction, so when the wheel slows down without any part touching. Block diagram. Here is a simple block diagram of how the eddy braking system works. It shows how the components interact to create a braking force without friction. Prototype. This slide shows a prototype of the eddy braking system. This helps us visualize how the system can be implemented in real-world vehicles. Advantages of eddy braking. Frictionless operation. Unlike traditional braking system where parts like brake pads and discs physically touch to create friction, eddy current braking works with magnetic field. Since there is no physical contact, there is no friction involved in slowing down the vehicle. This means no heat is generated due to friction, reducing the risk of overheating, and it also prevents the wear and tear that happen in system with physical contact. Low maintenance. Traditional brake needs maintenance because the brake pads, disc or other parts wear out over time and need to be replaced. Eddy current brakes, on the other hand, don't have any moving parts that wear down. There is no physical contact, so there is less stress on the components, making the system require less maintenance overall. No need for lubrication. In systems that rely on friction like regular brake system, parts need to be lubricated to reduce wear and ensure smooth operation. Since eddy current brakes don't use friction, no lubrication is necessary, making the system more efficient and easier to maintain. No wear and tear. Traditional brakes wear out over time because the friction between the part causes them to degrade, but eddy current brakes don't suffer from these problems because there is no physical contact. This results in less damage and a longer lifespan for the braking system, making it more cost effective over time. Highly reliable. Since the system is frictionless and have fewer moving parts, it's much more reliable. It's less likely to fail due to wear or overheating, which can sometimes happen with conventional brakes. This makes eddy currents very dependable, especially in high speed or critical applications like trains or high performing vehicles where reliability is the key. In short, eddy current braking offers significant advantage because it does not rely on friction, which means it's low maintenance, more durable and highly reliable over time. Frictionless braking. Since this system does not involve any physical contact, there is no friction. This eliminates problems like heat buildup, noise and material wear, making it a superior alternative to traditional brakes. Low maintenance and no lubrication. With no mechanical contact, the need for maintenance is drastically reduced. There is also no need for oiling or lubrication, making the system more cost effective and hassle free. No wear and tear. Unlike traditional brake pads that wear out over time, eddy braking system do not suffer from material degradation. This increases the lifespan of the braking system. Reliability. Because there are no friction-based components, eddy braking systems are more reliable and perform consistently over long periods without failure. Comparison with traditional braking. This slide shows a comparison between traditional braking systems and Eddy's contactless braking system. Traditional braking. It uses friction. Traditional braking system, like the one in most cars, rely on friction to slow down the vehicle. When you press the brake pedal are pushed against a rotating disc or a drum, and the friction between the pads and the disc generates the braking force. However, friction causes wear, which leads to the parts needing replacement over time. Requires frequent maintenance. Since traditional brakes use friction, the brake pads and disc wear down after repeated use. This means they need to be checked and replaced regularly to maintain the braking performance, which can lead to higher maintenance costs. Over time, you may also experience brake fade, where the brake brakes loses effectiveness due to heat buildup, wears out over time. As mentioned earlier, friction wears down parts like brake pads, disc or drums. The more you use your brakes, the more wear and tear happens. Eventually, these components need to be replaced, adding to vehicles' maintenance cost. Eddy current braking. No friction. In contrast, eddy current braking does not rely on friction. Instead, it uses magnetic fields to slow down the vehicle, meaning there is no physical contact between parts. Because of this, there is no friction related wear and it's a cleaner way to brake. Low maintenance. Since there is no physical contact in eddy current braking, there is less stress on the system. This results in low maintenance since no part wear out quickly. You don't have to replace the brake pads or disc, and there is no need for lubrication either. Highly efficient. Eddy current braking is not only low maintenance but also highly efficient. It's ideal for situations when continuous braking is required, like on train or in some electric vehicles. There is no risk of overheating due to friction, and the braking action is smooth and effective over time. In simple terms, eddy current braking is a more advanced and efficient way of slowing down a vehicle without the downsides of wear and tear and constant maintenance that comes with traditional friction-based braking system. Application of eddy braking. Eddy braking is useful in various fields including automobiles, high-speed trains, industrial machinery, amusement park rides. Conclusion and future scope. Eddy current braking is a superior alternative, eliminating wear and tear. One of the biggest advantages of eddy current braking is that it eliminates physical contact between parts, unlike traditional braking systems that rely on friction. This means there is no wear and tear on components like brake pads or discs, making it much more durable over time. Since the braking is done through electromagnetic forces instead of friction, the parts don't degrade, so the system lasts longer with minimal degradation. Reducing maintenance. Since there is no physical contact and no parts that constantly wear down, eddy current braking system require much less maintenance. There are fewer components to replace, and there is no need for regular servicing of things like brake pads or discs. This This significantly reduces maintenance costs and downtime, making it more cost effective in the long run. Increases reliability. Reliability is another key benefit of eddy current braking. Traditional systems can fail due to frictional wear, overheating or damaged components, leading to safety issues. But eddy current brakes are highly reliable because they are less prone to failure, have fewer moving parts, and do not face the same risk as friction brakes. They are consistent and stable even under high demand conditions, like when the speed trains or electric vehicles need to slow down quickly. The future of eddy current braking, optimizing with advanced electromagnetism and power electronics. In the future, eddy current braking systems can be further optimized by using cutting-edge electromagnetic technology and power electronics. For example, engineers could use stronger and more efficient magnets along with more advanced control system to make the braking action even more precise and energy efficient. Power electronics could be used to better manage the energy generated during braking, called regenerative braking, improving the overall energy efficiency of the system. This means that the energy lost during braking could potentially be recaptured and used to power the vehicle, especially in electric vehicles. Wider application in the future. As technology improves, eddy current brakes could be used more widely in various transport systems. They are already used in high-speed trains and some electric vehicles, and in future we might see them in aircraft braking systems, especially in electric planes or high-performance aircraft that need efficient and reliable braking. Electric vehicles could benefit from eddy current brakes because of the need for lower maintenance, frictionless braking system, and the ability to regenerate energy during braking. Similarly, high-speed trains which need to brake smoothly and safely at very high speed would find eddy current braking ideal due to its efficiency and reliability. Thank you.